Hi, this is Larry, and I've drawn this app, and I'm going to talk you through it. And I'm sorry with that little funny-looking line sticking over top of the drawing. It looks like a little shark swimming along. That was me just trying to figure out how to use this. So we have a rotating light located 14 feet from a wall. It completes one rotation every 2 seconds, and we're trying to find the rate at which the light projected onto the wall is moving along the wall when the light is at an angle of 15 degrees from the perpendicular. So I made a drawing of the situation. You see the little spotlight in red over on the left, shining a beam of light hitting at point Y on that right on the vertical wall. And then we have the dotted line, which is perpendicular to the wall, and its length is 14 feet. And Y is both the coordinate of where the light hits the wall, and it's also the length of that side of the triangle. So we're going to go through this related rates problem. Let me page up a little bit. So we have tangent theta equals is defined as y over 14. So y equals 14 tangent theta. Then we're going to take the y dt to see the rate at which that point y, where the light hits the wall, is moving along the wall with respect to time. So that's 14, and the derivative of tangent theta is secant squared theta d theta dt. Now, a couple of notes on d theta dt. First, the blue bubble below the yellow bubble on the right. We must always do d theta dt in radians. I can't go into that right now as to why that is, but believe me, you would get a really messed up answer if you tried to do theta in degrees. So use radians, and then above it, we have that the light rotates, complete rotation in 2 seconds. That's 2 pi radians in 2 seconds. That is pi radians every second. So d theta dt is pi. And I put pi in for d theta dt. Move this down a little bit. So we have now dy dt equals 14 pi secant squared theta. Now we'll put 15 degrees in for theta. And it doesn't matter here if you use degrees or radians. As long as your calculator is set to the correct mode, you'll get the same answer. Dy dt equals 14 pi times secant squared 15 degrees, and that is 47.1 feet per second. So I hope this makes some sense to you. If you have any follow-up questions, maybe you can post them as a comment. I don't really know. See you later.